All right, so the center is 0, -3. Radius is square root of 7. Let's try another one that has that coefficient of 1. So that was 86. 87. So same problem. This is the equation of a circle. X squared plus x plus y squared. Well, it's x squared plus y squared plus x equals 0. Group the x terms together and the y terms together and push all the constants over to the right, which there aren't any, so you just have 0 on the right. The coefficient of the x is a 1. Okay, so take that coefficient, divide by 2, and square it, and you get 1/4. Right, 1/2 times 1/2 is 1/4. So you add 1/4 to each side of the equation. Add 1/4 to each side in order to keep the equation balanced. So now that coefficient divided by 2 was 1/2. So this one becomes x plus 1/2 squared. The y, there's just y squared by itself, and in that case you don't have to do anything. There is no y term. There's just a y squared term. So this is what you're left with. This is the equation of the circle in standard form. So the center is x coordinate is -1/2. Right? So going back to the standard form here. X minus h squared, y minus k squared. Well, the y coordinate of the center is 0. The x coordinate of the center, so rather than being x minus 1/2, the x coordinate is not going to be 1/2, but -1/2. If it's a plus, you need to negate that number. If it's a negative, then it's just that number by itself. So -1/2, 0, and the radius is the square root of 1/4, which is 1/2. So 88 is very similar to these two problems, except you have to complete the square with both the x and the y in 88. An example where you complete the square with both would be, say, 85. So x squared plus y squared minus 4x plus 10y plus 13 equals 0. So group the x terms together, the y terms together, and move the constant over to the right by subtracting it from both sides. So minus 13. Take the coefficient of the x, right, divide by 2, and then square it. So 4 over 2 is 2. And when you square it, you get 4. So you're going to add a 4 with the x's. Plus, the coefficient of the y is 10. Take the 10, divide by 2, and square it, and you get 25. So you're going to add 25 with the y's. And then on the right, you have to add those same numbers to keep the equation balanced. right? So along with the x's, we had 4. Along with the y's, we had 25. So on the left-hand side of the equation, we've added 29. So on the right-hand side of the equation, we must also add 29. So this right here is x minus 2 squared. Right? 4 over 2 is 2. And 10 over 2 was 5. So this one is y plus 5 squared. This over here is 29 minus 13 is 16. Okay, this one is x minus 2 squared because that's a minus sign. And this one is y plus 5 squared because that's a plus sign. So the center is x coordinate 2, y coordinate negative 5, and the radius is the square root of 16, which is 4. All right, completing the square is, just once you've done it a few times, it shouldn't be too much of a mystery to you. We're going to do more of it in section 1.4. More of that in section 1.4. Okay. So that's some problems in these sections to get you started, on the assignment. The assignment is, the problems are very similar to what we've just done here in section 1.1 and section 1.2. Okay. Moving on to section 1.3. This is on lines. Okay, consider a line in the two-dimensional XY plane. So here's the x-axis, here's the y-axis, and let's just take some line in the plane like that. Any 2 points on the line define this number, this parameter of the line called the slope. So if I've got, let's call this point x1, y1, and let's call this point x2, y2. So x1, y1, and x2, y2. Now, if you take this right triangle defined by those 2 points right there, right, this length right here is x1 minus x2. And this length right here is y1 minus y2. Now here we're going to skip the absolute values, and we have to keep in mind that the point to the right is going to come before the point to the left when you do this subtraction, or the other way around. This is y1 minus y2, where you're taking the right hand point and the left hand point, right hand minus left hand along this line. And this is x1 minus x2, where you're taking the right hand x coordinate minus the left hand x coordinate. And the ratio of these 2 things, what's known as the rise over the run of the line. So the slope of the line is equal to the rise over the run, which is equal to, in terms of x's and y's here, well, the run is the horizontal distance, the rise is the vertical distance. So the rise is y1 minus y2 over x1 minus x2. Or it's the same as y2 minus y1 over x2 minus x1. Okay, the slope is given by any 2 points on the line. So the slope of the line is given is the same. Well, it's given by any 2 points on the line. If I chose 2 different points, like instead of this point and this point, I took this point and this point, and then I looked at this triangle over here, that ratio is going to be the same thing. The rise and run will be different. I mean, they're bigger in this picture I've chosen here. But that ratio is going to be the same. Okay, that does not change. Will give the same slope. Okay, so every line in the two-dimensional plane has a certain slope. And when you're calculating that slope, okay, make sure you preserve the difference between right and left. Is it right minus left or left minus right? Pick one, doesn't matter. So I usually do right minus left. So right minus left of the y-coordinates, right minus left of the x-coordinates. Okay, and that gives you the rise, the difference in the y's, over the run, the difference in the x's. So, for example, so here's a line. It's got points 1, 2, and points 5, negative 1. What is the slope of this line? All right, 1, 2, and 5, negative 1. Well, the slope is equal to the rise over the run. Right, so you can also think of this as the change in y over the change in x. So I will do right minus left. Change in y is minus 1, minus 2. Let's not say change, let's say difference in y. Over the difference in x. Rise over run. Difference in y over the difference in x. So minus 1, minus 2, and then 5 minus 1. So this slope is minus 3 over 4. Okay, so slope minus 3 over 4. So from left to right, if the line goes downhill, it's a negative slope. If it goes uphill, it's going to be a positive slope. A positive slope goes up, and a negative slope goes down from left to right. Alrighty. So now there are two basic ingredients that are necessary to define a line. Okay, one, the slope, and two, a point on the line. So we'll call it, say, A comma B. Okay, given a slope and a point on the line, you can get the equation of the line, an equation of the line. So given these two, given these two ingredients, we can get the equation of a line. So the equation of the line can be given in two forms. Given these two ingredients, we can get an equation of the line as follows. So, no, let me see. Given these two ingredients, we can get the equation of the line as follows. Right. So, the slope, we'll call it M, and some point AB on the line. Okay, the point slope form of the line will look like this. So y minus b is equal to m times x minus a, where you have to have this parentheses right there. This is called the point slope form of the line. And any point xy on the line must satisfy this equation. So, for example, find the equation, the point slope, so the equation of the line with slope equal to 2 and containing the point, let's say 1 comma 3. We'll say minus 1 comma 3. So find the equation of the line with slope 2 and containing the point minus 1 comma 3. So this right here is the A. Right, so the point AB is equal to minus 1, 3. So A is the x-coordinate, B is the y-coordinate, x-coordinate negative 1, y-coordinate 3, and then the slope M is equal to 2. So you just plug those items into this right here. So we have y minus 3 is equal to the slope 2 times, parentheses, x minus 1. Right? Y minus 3 is equal to 2, and then you have to have this parentheses, x minus 1, right? It's y minus b is equal to m times x minus a. So cleaning up that expression, we have y minus 3 is equal to 2 times x plus 1. So, for example, if this is the point, minus 1, 3, right here, some other point on the line will satisfy, any other point on the line will satisfy this equation. So let's pick a value for x. Like x equal to 4. So now we can get the corresponding y coordinate. So you take that x value, plug it into here, and then you'll get a solution for y. So y minus 3 is equal to 2, 4 plus 1. So y minus 3 is equal to, so this is 2 times 5 is 10. Add 3 to both sides, and you get y is equal to 13. So if you take x coordinate equal to 4, then you will get y coordinate equal to 13. And any other point on the line that you would like to find, if you know one coordinate, if you know the x coordinate, you can find the y coordinate. If you know the y coordinate, you can find the x coordinate. A second form for the equation of the line is y equals mx plus b. This is called the slope-intercept form for the line. Okay, the m is equal to the slope, and the b is equal to the y-intercept. M is equal to the slope, b is equal to the y-intercept. So it'll look something like this. So right here is b on the y-axis. Again, this is the x-axis, that's the y-axis. And this point b right here is the y-intercept. And that shows up in this form for the equation of the line. So, for example, in the last example, right, this is the equation of the line with slope 2 So this equation is for the line with slope equal to 2 and y-intercept, and passing through the point minus 1, 2. Transform this equation into slope-intercept form. And find the y-intercept. And then let's sketch the equation, find the y-intercept and the x-intercept. And then graph the line. Okay, so y minus 3 is equal to 2x minus 1. So what you want to do is to push all of the constants over to the right and then distribute this through here. So first let's do the distribution, 2x minus 2, and then let's add 3 to both sides, and we have y equals 2x plus 1. So now this has the form y equals mx plus b, right? It has this form. So the y-intercept is 1 and the slope is 2. Well, we already knew the slope is 2. So slope is 2, y-intercept is 1. So we know so far that the y-intercept is 1. This is the x-axis, this is the y-axis, this is y equal to 1. Now, in order to sketch the line, we would need to find another point on the line. We already know another point on the line. We know it passes through the point -1, 2. So you could graph -1, 2, that would be up here, right? And then sketch the line like that. But I want to know another point on the line. I want to know the x-intercept. Where does the x-intercept happen? So the x-intercept, okay, is found. So let's get some more space. The x-intercept is found when y is equal to 0. So plug in y equal to 0, solve for x. Right? The y-coordinate will be 0, and then you just have to figure out what the x-coordinate is supposed to be. So put in y equal to 0. You can do it either in this equation of the line or that equation of the line. So 0 is equal to 2x plus 1. Subtract 1 from each side. And minus 1 is equal to 2x. Divide by 2. And we have minus 1 is equal to, or minus 1/2. No, wait, hold on, what happened? Minus 2 plus 3. Minus 1/2, 0, that's not correct. Minus 1, 2. Oh, this was a plus. That's plus 2, so that's a 5. Alright, so that was supposed to be a 5. Oh, what? Wait. Minus 1, 3. Y minus 3, so x plus 1, y minus 3. X plus 1, y minus 3. Plus 2. Oh, well, it is 10:55, 10:56. I'll finish this up and post it for you. And then I am going to be in my WebEx room from 11:30 until 12:30 today, if you want to stop by. And I will send you an email, with the link, okay? And in just a little more, in a few moments here. No, the x-intercept is when y is equal to 0. The y-intercept is when x is equal to 0. Okay, so I'll finish that up and then I'll post it and we'll talk about it more tomorrow.